So a hair salon provides haircuts for children and adults. Let's define our variables right away. These would be children and adults, right? Number of cuts, right? X and Y is greater than or equal to 0. Okay. Develop the system of inequalities. The salon books at least 5 adult appointments for every child appointment. So this is probably what threw you off a little bit. So let's do that one first. I'm going to do that right next to this. Okay, so I like to have the Y and the X, right? At least 5 adult for every child appointment. Okay, so you're going to put the 5 in front of the child appointment because you want this, right, to be greater than 5 times whatever the children haircuts would be. All right? So for every, you have to think of it, for every child haircut, you want 5 times of that for Y. Okay, so that's the wording there. On the test, I'm not going to ask you to graph one like this, but I will ask you to write it. Okay, so you got to kind of be careful there. So for every child, you want 5 times that for the other one. And if you're not sure, you do a little test, right? Check. If X is equal to 1, then you should have this, right? Y is greater than or equal to 5. So if X is 1, if you have one child haircut, then now you're saying that Y has to be greater than or equal to 5, right? So you're doing a little check. Does that add up? Because if you had it the other way, it would actually not work out. You would have 1/5 of a haircut. Okay. Develop a system. So we've done that one. Let's do this one first. 1 mark for that. For the next one, it usually the salon books at least 90 appointments per week. I hope this one you were able to get at least 90. Okay, so that's another mark there. An average child appointment takes 20 minutes. An adult one takes 45. So that's just information there for you for the length of time. So among all the stylists, there is 160 hours available to cut your hair. So in this case, you need to go 20x plus 45y, right? And there's up to that much available, so it has to be less than or equal to what? Can you use 160? You cannot because it's minutes, minutes, hours. So you just do 160 times 60, and that would be 9,600 minutes. Okay. So 9,600 is what, so this is a half mark here for that step, and this would be a mark for writing it out. This is one of the harder ones, by the way. So, all right. So how would you graph this? For the X plus Y is greater than or equal to 90. This would be 90, 0, 0, 90. So just make sure you write this down if you haven't done it, okay? Rewrite it. Y is greater than or equal to negative X plus 90. This would be solid. True is where? Where is it? It is above, right? Because it's pointing, it's greater than. So we shade below. We want to use reverse shading when we do a system. Okay. Next, let's do this one here. This one is tricky, but it's already rewritten. Okay. So we need another point. So 0, 0 is point number 1. You want another point. So I'm going to let X be 10, just because I'm looking at some of the numbers here. I'm looking at 90s and stuff. So if X is equal to 10, what's Y going to be equal to? 5 times 10. So that's 50. You can pick any X value you want. Okay, so point number 2 is 1050. That's point number 2. So you've got your 2 points. It's instead of x-intercept, y-intercept, you're using the origin, which is both, right, x and y intercepts, and another point here. You're going to connect these two. Solid. True is above the line. Right? Therefore, we're going to shade below. All right? So there we have both of them rewritten. And now we need this one here. I'm going to just do that up here. 20x is equal to 9600. X is equal to 480. So it's 480, 0. Okay, and then you do the y-intercept right next to it. 45y is equal to 9600. Divide both by 45, and you get a decimal there. You get 213.33. That's okay. X and y intercepts are right there. And let's rewrite it. If you rewrite this one, it's a little messy. I'm going to do that right here if I can. So 45y is less than or equal to negative 20x plus 9600. Divide both sides by 45. Y is less than or equal to, I'm just going to leave everything as a fraction. I'm going to zoom into that one. That's a bit small there, guys. Sorry about that. But this is the inequality that I'm going to type into my y later on. So in this case, I have solid lines. The true region is below. Okay. I'm going to shade above. Circle that part. So I'm actually going to highlight for every single one. I'm going to highlight my inequality and where I'm shading. Inequality and where I'm shading. Inequality and where I'm shading. Okay. So now I need a scale that works out. Why don't we first type this all in? We should all at least write down the inequalities rewritten for every single one and type it into your calculators, right? That is, I would like you to do that. So we all have the same color lines. Let's start with this one. Let's start with this first. Negative x plus 90. Even if you haven't graphed it, that's fine. And then we do 5x. And then we'll do that very ugly one there. Negative 20 over 45. X plus. I leave that as a fraction. Why? Because it turns out to a decimal, okay? 213.33. That's why I leave that as a fraction. My calculator can handle that, no problem. Okay? So we've got these three in there, and let's go ahead and graph this. We're probably going to have to change our window. Right? And you've probably noticed that in word problems, we don't have the flipping of the symbol, right? Because you don't really divide by negatives, hardly ever. Okay? So let's graph this. Mine is bad, so I'm going to go, let's all reset. Let's do zoom standard. And the only one you see is that 5x, right? We got to go to our window and change things. I have for my y, I have a y-intercept of 90 here. Look, so I'm going to change my y max to 100, and I'm also going to change my x max to 100 because I have 90, 0, right? Change them both to 100. Let's see what happens here. I only have 2 lines. Which one is missing? Oh, here. I wasn't looking at this one. Look at this. 480 and 213. So let's go back to our window. My x max, I'm going to change it to 500. And my y max, I'm going to change it to 250, let's say. So, right, this came into into play here, so I have to change my window again. Let's give it a graph. And so that's what it's supposed to look like. Okay, that's what I'm aiming for. So let's go ahead and come up with a scale here on our graph. Okay. So I'm going to go to 500 down here. 100, 200, 300, 400, 500. That'll do it. I'll just label every other one, and I'll call this kids cuts, and this would be adult cuts. And for my Y, I need to go up to 250. So I'm going to go 50, 100, 150, 200, and this will be 250 right there. So let's graph whichever one you want. I'm going to do the 90. So 0, 90, and 90, 0. It's right here. So I'm just going to graph that line. Okay. This is my x plus y is greater than or equal to 90 line. Then I have the 5x, and I have to do a little bit of work there. Okay. 0, 0 is part of it, and then it's 50 is right there. 1050 is right there. 1050. So you graph that line. And this is the line y is greater than or equal to 5x. And then the last one is 0, 213, way up here, and 480, which is almost by 500, right? So close enough is good enough. You graph that line. And then you have that one as 20x plus 45y is less than or equal to 9600. Okay, so now we shade. I'm shading this one. I'm shading below this one. Okay, so that little wedge, I'm doing reverse shading every time when it's a system. Okay, reverse shading there. The 5x, I'm shading below as well. So this one is tricky. Which way is below? Because it's almost vertical. This way is below here. Okay. So I'm going to do this shaded right here. And the last one says shade above. Okay, this one right here says shade above. So I go to this line and I shade everything. Okay. So in a sense, this is your solution region right here. How many corner points do we have there around the solution region? We've got 4. Okay, we've got the 2 that we know already, and then we've got this one and this one. Okay. So let's state all corner points. So I'm just going to read that one, 0, 90. And then there's 0, 213, 33. I read that one as well. I need to round that one. 0 to 213 is fine. Comma. These two, I'm just going to tell you what they are because of time. This one is 1575. This one right here. And that one is 39.18. 195.92. That rounds as well. So that would be 39, 196. I'm going to highlight that part that I did round it, and same here, right? So those are the 2 I needed my calculator for to get them. Okay, so this is the new part right here. This is what we started with yesterday. State the objective function which would determine the total number of hours the salon spent styling hair. Hours. So you got to start with a capital letter like that. And what would be the objective function in this case if you just want to know how many hours have been, I shouldn't have said hours, time. Can you change that? Total time? Minutes is fine. Change the hours to time. Okay. So in this case, you just look up there. Is there any hint for time? And there is, right? It takes 20 minutes for a children's haircut, and it takes 45 minutes for an adult's haircut. That is my objective function. Okay, that's the new part. So that'll give you, if you feed any of these points into it, it will tell you how many hours were spent. There. So which combination would result in the greatest time spent styling hair? Let's just do this, okay, for time's sake. 090, we plug it into here, right? H is going to be, just write this down, it's going to be 4,050 minutes. If you plug in 0 to 13 into this objective function, you get 9,585 minutes. If you plug in 1575, 15 children's haircuts, 75 adult haircuts, into H, into this one, you get 3,675, and then the last one here, 39,196, you plug that into H, you get 9,600 minutes. So in this case, which one maximizes? This one right here. Cutting 39 kids' haircuts and 196 adult haircuts will maximize the amount of time spent. Okay? The back side, I'm just going to let you see the key here. These are the three inequalities that you're supposed to have gotten. And the POIs, you're supposed to use your calculator to find them. There are only two POIs. I'm going to show you them in orange. On the graph, look at this. The x-intercepts and y-intercepts do not count as POIs because it's not a word problem. Okay? So it's just that. And so these ones I wanted you to use the calculator, type these equations into your calculator and get it that way just to practice that.